Hi, I'm Kuruih. We are from Group K. This is our group members. They are Chang Kajun, Mi, Kuruih, Kong King, and Anja Chen. What is Lajak kuruih? Lajak kuruih is a health supplement diet table which manufactured by Lajak Food Factory. There are 15 types of Lajak kuruih table. So our group doing for the Lajak kuruih cake. And there are 200 sample observations are selected from the 3 production shift run daily, which are morning, evening, and night. This project objective is to examine the quality of table production for a particular type of Lajak kuruih table. I'm going to explain the part A, summarize data in numerical form, tabular form, and graphical form. First, numerical form. We need to do the table for the summation of data, sum of weight, sum of tensile strength, and sum of reactive density, and depends on the 3 shifts. We need to calculate the grand total. And we do like the previous step for the table of average of data. This is the numerical data obtained from the sample. Do you know what is descriptive statistic? Descriptive statistic is like median, mode, standard deviation, sample variance, and others. We need to do the descriptive statistic for the weight, reactive density, and tensile strength. Next, tabular form. We need to do the tabular table for the weight. This is the class interval for the weight, and this is the frequency for each class interval, and we need to calculate the grand total. Next, we need to do the same like previous step for the reactive density and tensile strength. Then we need to do the graphical form. We need to do the summation graph. There are 3 colors. The blue color is sum of weight, the red color is sum of tensile strength, the green color is sum of reactive density, and we need to depend on the 3 different shifts. Then we need to do the average graph, also like almost same as the previous summation graph. Then next is the weight graph. For x-axis is the weight and y-axis is the frequency of weight. And reactive density graph, the x-axis is the reactive density and y-axis is the frequency. And last, we need to do for the tensile strength graph. X-axis is the tensile strength and y-axis is the frequency. Thank you, that's all from me.
Hello, I'm Gong Zhi. Now I will present the part B. For part B, we need to find that is there any significant evidence that weight of standard tablet produced by manufacturer follow the normal distribution with 350 mg with standard deviation of 40 mg. For this question, we use Goodness of this tab to solve it. Goodness of this tab divided into 4 parts, which is hypothesis statement, test statistic, rejection rule, and conclusion. So first of all, for the hypothesis statement, we let the H0 be the weight of standard tablet follow the normal distribution, and let the H1 be the weight of standard tablet does not follow the normal distribution. Then before we move to test statistic, we collect our data by creating a frequency table with range of 5. Next, for the test statistic, after we do the frequency table, we need to find the probability for each range. Then we can find the expected value by multiplying the number of samples, which is 200, with the probability. For last column, we use the formula there to find the value. After we complete table, we can find the chi-square test through the table and find the total value of last column, which equal to 10.965. Then we go to the rejection rule. First, we use the table of chi-square distribution and find the value of chi-square with alpha equal to 0.05 and degree of freedom equal to 11 is equal to 19.6751. Next, we see the diagram at the side. We can see that the value found from the table of chi-square distribution acts as critical point. If the value of chi-square test greater than it, which is the standard region, we will reject H0. If the value of chi-square test smaller than it, we will accept H0. So in conclusion, since chi-square test is equal to 10.965, which is less than 19.6751, so we fail to reject H0. Therefore, this is the significant evidence that Lajak tablet can produced in December 2020 will follow the normal distribution. And that's all from me. Thank you.
Hi, I'm Anja Chen. So I will explain the part C. Is there any significant difference between the platelet weight from the different shifts? The method we use is one-way ANOVA in Microsoft Excel. The purpose of using this method is to investigate the difference exists between platelet weight from the 3 groups of the shift. For the hypothesis statement, our H0 is no significant difference exists between platelet weight from the different shifts. and H1 is significant difference exists between platelet weight from the different shift. This is the result that we divide into 3 groups, which is morning, evening, and night shift. And this is our output summary of one-way ANOVA from Excel. We use 5% of significant level, which is alpha equal to 0.05. From the one-way ANOVA, the result of p-value is equal to 0.28638. Well, the rejection rule, if p-value is greater than alpha, then H0 will fail to reject. If the p-value is smaller than alpha, then H0 will reject. So, in conclusion, based on our output, p-value is equal to 0.28638, which is greater than 0.05. Therefore, H0 will fail to reject. We can conclude that there is no significant difference exist between tablet weight from the different shift. That's all from me. Thank you.
Okay, my name is Chang Jun. So I'm going to present about the party relationship between the relative density and tensile strength, and also predict the tensile strength at a given relative density. So the studies has claimed that the pure Lajak kuruih tensile strength depends on the relative density and regardless of the production shift. So in order to predict the tensile strength at a given relative density of pure Lajak kuruih, we have to perform the linearity regression model. And in this model, it consists of 2 variables, which is the independent variable, tensile strength. Dependent variable is the relative density. So from the exact analysis result, we can obtain the correlation coefficient R is equal to 0.84. So from this table, we also can obtain the best estimator for the intersection to the y-axis, alpha hat, and gradient of the linear line, beta hat. And these 2 variables will be used for the calculation after this. So simple linear regression equation can be obtained as below. So we substituting the alpha hat and beta hat obtained before this, so we can get this equation. So we want to determine the tensile strength at a given relative density. So we're substituting the relative density value into this equation. So this is the relative density line fit plot. The blue color is the tensile strength from the data sample, and the orange color is the predicted tensile strength. So we need to test for the linearity of the regression. So it consists of 3 outcomes, whether it is positive linear, negative linear, or non-linear. So we will perform the hypothesis statement by testing the hypothesis about the slope B. We can actually test the linearity of the simple linear regression model. H0 is beta is equal to 0, H1 is not equal, beta is not equal to 0. So we will use the t-test approach at a 95% of confidence level. So we can get the t-test is equal to this value, and the probability that greater than t-test is this. So comment on the validity of the model. So the R is equal to 0.8, which is close to the unity, and it implies that there's a strong positive linear relationship between the relative density and tensile strength. So p-value for beta, which is 1.228 exponent negative 55, which is lower compared to the significant level. Alpha equals to 0.05. Therefore, we reject the H0 and conclude that beta is significantly not equal to 0 at a 5% of significant level. So, which is implies that the strong linearity relationship between these 2 variables does exist. So, we have 95% confidence in the linearity relationship between these 2 values is valid. So, there's another alternative approach to test the significance of the regression, which is the ANOVA method. So as a conclusion, the status of the production in December 2020, there's a significant evidence that the Lajak laku care tablet produced in December 2020 do follow the normal distribution proposed by the manufacturer. So there is no significant difference exists between the Lajak laku care tablet weights from the different shifts. So the prediction tensile strength with a relative density of 68%, 74.3%, and 80.1% are shown as below. So there is a strong linearity relationship between the relative density and tensile strength. This test has been conducted so that the tablets are uniformity at every batch produced, so that the further corrective measures can be taken at the shop floor. So that's all from our group. Thank you very much.